Laws of exponents. We're going to look at 7 different laws. The first is that any number raised to the first power is just itself. If you'll remember what an exponent is, it tells you how many times to multiply the base number times itself. So if you're multiplying the base number times itself, well, just one time, then that's just that number. Like 2 to the first power would just be 2. Or negative 3 to the first power would just be negative 3. The second rule says that 1 raised to any power is 1. Because all you're doing is multiplying it 1 times itself, and no matter how many times you multiply 1 times itself, it'll always be 1. So for instance, like 1 to the third power, that means 1 times itself 3 times. 1 times 1 is 1 times 1 is 1. So it doesn't matter how many times you multiply 1 times itself, you'll always get 1. The third law says that any number raised to the 0 power is 1. This is one of my personal favorites. I think it's pretty cool. Like 8 raised to the 0 power. It's just 1. Or negative 10 raised to the 0 power. Again, just 1. Or even say like a half raised to the 0 power. Still 1. Any number raised to the 0 power is always 1. The fourth law is when you're multiplying with the same bases. So notice A and A, our bases are the same, but we have different exponents. When you multiply numbers with the same bases, you add the exponents. Let's look at why. So say we were doing 2 cubed times 2 to the 4th. Well, what that really means is 2 cubed is 2 times itself 3 times, so 1, 2, 3 times, times 2 times itself 4 times, so 1, 2, 3, 4 times. So we've multiplied 2 times itself a total of 7 times. So instead of going through all of this, we can just use that rule that when we multiply numbers with the same bases, we simply add the exponents. And then you could simplify from there. The fifth rule is pretty similar to the fourth rule, except we're dividing numbers with the same bases. So instead of adding our exponents, we subtract our exponents. For example, if we were doing 2 to the 5th divided by 2 cubed, what we're really doing is 2 times 2 times 2 times 2 times 2 divided by 2 times 2 times 2. So that's 2 to the 5th, 2 times itself 5 times, divided by 2 times itself 3 times. Well, we can simplify by canceling. 2 divided by 2 is 1, 2 divided by 2 is 1, and 2 divided by 2 is 1. So what we're left with then is simply 2 squared, or 4. So instead of doing this, we can use our rule that when we're dividing numbers with the same bases, we simply subtract the exponents. And that saves us a little bit of time. 2 to the 5th divided by 2 cubed, 5 minus 3 is 2, so it's 2 squared, which is 4. It also works if your denominator, the exponent on your denominator, is larger. Let's look at one of those. So that'd be like 2 squared divided by 2 cubed. So you still subtract your exponents, so it's 2 squared minus 3, which is 2 to the negative 1. And then you would simplify that by bringing this to your denominator, 1/2. The sixth rule says that when you raise a power to a power, like a to the n raised to the m, you multiply your exponents. So, for instance, with 3 squared cubed, what that really means is 3 squared times itself 3 times. So that's 3 squared times 3 squared times 3 squared. 3 squared times itself 3 times. 3 squared times 3 squared times 3 squared is 3 to the 6th. So all you have to do is multiply your exponents. 2 times 3 is 6, 3 to the 6th. The seventh rule says that when you have operations inside parentheses that are raised to an exponent, then each term inside those parentheses is raised to that exponent. So, for instance, like 2 times 3 squared. That is 2 squared times 3 squared. And again, you could simplify from there. Left off my n there, that's important. Now on this next one, same thing, just with division. So a divided by b, that quantity raised to the n, would be a to the n divided by b to the n. So everything in the parentheses is raised to the n power. So it'd be like doing 4 divided by 3 cubed. So that'd be 4 to the third divided by 3 to the third. And then again, you could simplify. And those are our laws of exponents.